Oh, there you go. It works. I didn't know how this app worked. I flushed and filled my phone. I've changed my phone number. Getting too many spams, spam texts, etc., etc. My emails remain the same. My name is Jason Wampler. This is another episode of The Rocket Minute. Again, I'm your host. I swear to God, man, I'm the only one. Having some security issues. We're having some issues with Google security. You know, guys, if you, I don't know, man, if you don't put at least one door on the bottom level of your building, nobody's going to be able to get in. So lighten up on the security measures. It's just me in my room with some tools and a couple of toy rockets. I don't really think that anybody's going to try to hijack my channel to download a virus on the internet and announce their plans for world domination and colonization of our species and other planets in an effort to fight off the effects of Darth Vader and his empire. I just don't think that's going to happen. So you can relax your security grip on my channel. I'm the only one who uses it. So when I have help, anybody else comes in besides, where is she? Valencia. Sorry, there she is. Here's Valencia. Hey, baby. How you doing, honey? Valencia wants a hot date. She's not getting one. I don't need a pregnant cat. Anybody else but Valencia or Paxton, which is out, who is outside on top of cabinet, on top of the stove. So those two cats are involved. They don't contribute, but they're involved. Anyway, that being said, I'm the only one. So anyway, my name is Jason Wampler. This is The Rocket Minute. No more political commentary. I did want to show you some things, though. Guess what? I got my glasses on. I got paid. I got this guy back. So what are we going to do? I'll tell you exactly what we're going to do. We are going to take our magic marker, which I always forget to bring from the car. And I swear I'm going to have the thing grafted to my forehead so that I remember. We are going to take ourselves a pen, ballpoint pen. I'm trying to play a disc and the thing is terminally corrupted. You know, I think the little aluminum strips on the DVDs or the CD disc or DVD disc, I think they melt. They fall out of place from overuse. Let's find ourselves a measure. Let's just go with the width of this blade. I'll show you why I'm doing this. Why the hell am I doing this when I have some place to sit? Get there, just, okay. See why I need 4 arms and not 2? I swear. I put in for the upgrade, but the factory is ignoring my request. Alright, here we go. There's that line there. And I need an equidistant line on this side there. I'll show you why I'm doing this in preparation of... Well, this CD is really starting to irritate me. And pens don't write that very well on PVC, no matter what. Put that away, put that back on that. You know, I tell you, it's really frustrating how fast time goes. If I stay in one spot, I can't beat how fast time goes. The older you get, the faster it goes. I tell you what. By the way, my email is waca2023@yahoo.com. Also have an alternate email at gmail.com. It's waca2027. 2027 is a special year. I'm not going to tell you why right now, but let me make sure this is working right. Okay, yeah, good, we're still going. I'll tell you later. Not too many personal secrets are things that I feel like sharing. I don't feel like sharing too many personal secrets, etc., etc. But that's pretty much that. Now, here's what I'm going to do to prep this body. Well, what am I prepping it for? I'm not going to tell you that. I'm just going to make you watch. Okay, I get this off. And here we go. And here we go. Okay, so prep. You got my tool here. Love this guy. Love this guy. Love the cutter on the top as well. But I have to put my glasses on. I need to go out of frame too. Take care of some business here. Hold on. Okay. Electrical tape. I need to get another roll of it. Maybe sparing with my expenditures. Sparing expenditures. Now I found it. A lot quicker than the last time I tried to look for it and didn't find it. I found it eventually. Now I'm going to take this tape and I am going to wrap it around the base of this fuselage as it sits on top the two upper motor tube housings. So I don't have a name for those things. It flows off the tongue. But all things being equal, and they are not, I'll figure something out eventually. Boy, this disc is really crashing. Such is life. I just watched a movie called Ex Machina. I sure do appreciate the female form, but a little bit too much use of it in the movies in its naked form is not necessarily entirely appropriate. All things being equal, I like Oscar Isaac. I think he's a great actor. So, yeah, I love women a little bit too much anyway. So I'm wrapping this. I don't know if you can even see that. I can barely see myself to make sure you see that. But I see what you see, and I'm not sure I see myself. And I want you to see me. God help me, I'm getting confused. All right, here we go. That's enough. That's enough, Jason. Control yourself. I have the scissors right here, so I'm not absolutely completely absent-minded. That's absolute. You know, they say dementia starts very early. It starts about 20 or 30 years before it fully takes effect and really kicks in and debilitates a person's life. I'm almost positive that I'm having the early stages of Alzheimer's or dementia where my memory is starting to short circuit and gap. So I don't attribute it to the overuse. I attribute this to the overuse of my brain. I just think I got, I kind of got leftovers when I got the brain. I'm taxing it to death, but it's failing regardless. Maybe I should take better care of my health. Somebody told me that. I think I heard that somewhere anyway. Okay, so here we go. Okay, so I draw the line there. I'm going to show you why why I did that. I masked this area of the trunk here, and I marked this with tape here, or with, good grief. My mind is working faster than my mouth. This is an ink pen. Didn't show up very well. I'm going to go get that red magic marker that I got with the Milwaukee name on it. I got that from McFadden. It wasn't that expensive. It's only like $1.50. Actually, you know what? No, it might have been free. Because Milwaukee does give stuff away from time to time. The reason I'm doing this in my professor's shirt, I have one other that's Hawaiian, dark, distantly related Hawaiian. It is Friday, but every day for me is casual. So here we go. This is a Warrior brand variable speed oscillating multi-tool. These things are wonderful if you can afford to keep them, and I'm going to have to afford to keep them because I need this tool. And this has a bimetal blade on it, which means you can cut wood or metal. I'm going to be using this to cut aluminum metal tubes for loading the cartridge in for dry fuel rocket motors. I don't want to even talk about that right now, but it's dual purpose. It costs $1 more than the other one, which just cut plastic and wood and leather. This one cuts plastic, wood, leather, ceramic, and metal. Like 5. The other one only cut 3 or 4. So for $1 more, I got something that does a little bit more. And I know I'm going to be cutting wood, or not wood, but I'm going to be cutting phenolic, which is related to wood, kind of. At least it looks like it. Metal and aluminum and plastic, which is what I'm cutting right now. This is a delicate operation. So what I'm going to do, this is interesting. What the hell? Okay, so this disc straightened out. What I'm going to do is I'm going to use this guy. This half moon blade, it oscillates. It jigs back and forth by about roughly 1 or 2 millimeters. It's got a little saw teeth on it. And what I'm going to do is do a straight cut, or not straight cut, let's be an angle cut. Looks as relative to the long axis of the rocket, I would say at about roughly 37 to 38 degrees, maybe even 35 degrees. I want a clean cut. Though I say 35 because I'm going to start at this point right here, and I want both sides to be flat and even. In other words, if you place something, this rocket stands upright on a flat surface. Everything's square here and square here. This side will be completely vertical, each side relative to that invisible sandwich plane we're talking about. With this compound section of the rocket, these will be evened up. The one side and the other. So you, like a house has a roof that slopes on one side. Well, one side of the roof on the back end of the house, it's got to be the same height as the other other side of the roof on the front of the house. Even though they're on a slant, the two sides of the slants, they have to be on the same plane. Again, for the sake of handling characteristics, a correct flight of the rocket and launch off the pad, not creating danger, not creating CATO, not creating catastrophic loss, because we're putting a lot of time in this rocket. You want your pant legs evened up. Cross your T's, dot your I's, do all your data and calculations. But with actually building a rocket frame, it's as much craftsmanship and intuition as it is mathematics. I'm not really using much of anything except two things: right angle mechanics and the rule of proportions. There you go. Now I have two theories to write books about. Maybe I'll just include it in one book. No pictures of me on it, I promise. I don't want to threaten people with stuff like that. And here we go. I have to get up and push the play button because I think I'm going to revisit this movie Ex Machina, and the CD seems to be working a lot better now, or DVD, or whatever the hell you want to call it. What the hell do you want to call it? The other thing is Blu-ray, so that must be a DVD. By the way, Blu-ray was a complete failure. You got exactly the same thing, but you had to pay more money for it. And that came after, not before, DVD. So I'm just kind of wondering what marketing genius came up with that. But it is funny. To a certain extent, but somebody lost a lot of money. That's not funny. It's not funny to them anyway. I can't stop laughing about that. I didn't buy one single Blu-ray disc. I never bothered to buy a Blu-ray machine. I'm thinking to myself, something doesn't smell right. Something's rotten in Denmark on this one. That's a saying, by the way. Why am I paying more for the exact same thing? And they're showing you pictures of the picture quality of a Blu-ray disc on your TV, which is playing a DVD that's advertising the qualities and merits of a Blu-ray over a DVD. So it's just funny as hell, man. And it goes back to that day I'm thinking of. I swear to God, man. Advertisers thought people were so stupid they could advertise picture quality of a TV on your TV. So you're seeing the picture quality of a TV they're asserting is superior to your TV on your TV, and you're going like, wow, that does look better. So you go out and buy their TV. Oh my God! But I don't want to be the laughing rocket scientist, but I just thought that was kind of strange. And I'm thinking to myself, I don't understand. How can you see the quality of that TV on our TV when you're bragging that that TV on our TV is better than our TV? Anyway, well, like, gifts in life is being able to make yourself laugh. And I gotta tell you, if you aren't gonna spit nails and take a rake to somebody's head or bash the side of their car in because you're so angry at them, you just laugh it off. And I think I prefer the non-violent method because I really, really, really don't want to end up in prison. I'm not a violent person, but I can blow my stack. Anyway, okay, so wish me luck. So you kids understand what we're doing. Okay, here we go. We're cutting from look at the side. The line right there. We're cutting a straight line from here to here. So let me attempt this right now. Okay, this is variable speed, by the way. You're not gonna be able to hear me talk, so I won't bother talking. I'm gonna try it with these speeds 1 through 6. So halfway between is speed number 3, and line that up a little notch. Let this machine repeat itself. Here we go. I don't think this is gonna work though. Okay, it's working. I just want to make sure. I'll show you after I cut it. If I screw up, I'll tell you about the mistake I made. But if I get it right, I'm going to brag about how wonderful I did. And looking at it, the wrong way. Okay, you gotta look at it from the side. Just hope you got it straight on both sides. You know, this speed seems to be just fine. But we're only gonna turn it up to number 3. Number 6, it really rock and rolls. And it's kind of dangerous. And oh my goodness, it doesn't go all the way through. You know what? I knew I should have got the solid blade. And it doesn't have this band here that interferes. That takes away about 10 millimeters of cutting depth to go down this tool. I won't get too technical. So here we go. Hold it sideways. Everything has to do with holding things at the angles they're supposed to. Oh goodness. Okay. I'm going to turn it off. If it's variable, you don't want surprises. If for whatever reason you hit the switch, the thing starts at full speed, it's going to jump all over the place and tear up the carpet. So when you turn these off, variable speed, just to be safe, turn it back down to 1. It starts real slow. It only zaps. It only oscillates so quickly. Now, but you see what I've done. Okay. So now I kind of got lucky, but I do the sandwich thing, the three business ends of tubes, sandwich plane thing, and I'm looking even space here, so it's dead straight. So I'm looking there. Unfortunately, this height is higher than that height. Let me explain to you then again the rule of the right angle mechanics. This needs to cut into this at a right angle with the imaginary sandwich plane going between these 3 of these tubes, so it's even on both sides. That's what I would call right angle mechanics. That's where right angle mechanics, which is very, very, very basic version of a branch of geometry. I'm almost positive somebody else has thought this up too. When you're designing and building rockets, I got to tell you folks, you're going to make extensive use of knowing and understanding ABC, 1, 2, 3, X, Y, Z, yaw, pitch, and roll. That not just in maneuvering, but in designing and building rockets. It's strange how 3-axis geometry, as it relates to right angle mechanics, has almost everything and anything to do with designing and building a rocket correctly. I don't want to overwhelm you with charts and graphs. That's how nerdy people make themselves feel better than other people, and they think that their brains have muscles, therefore they're going to garner a date with a hot-looking brunette, in my opinion, on a Saturday night. They're not. Just because you have hair and a PhD doesn't mean you're going to attract the women. Sorry, guys. You got to be a real man. I'm not even going to talk to you about that. Okay, so, but anyway, again, I want to show you what I'm doing and also why I'm doing it. I'm going to leave the tape on. This is a little tough in the sense I couldn't get all the way down there. So let me try this again. I may need to buy another attachment for this guy. Going there real slow. Okay, see, so that way I didn't have to bend it back and forth and break this piece off. Why am I doing this, you might be asking? Well, if you keep asking, it'll irritate me to the point where I'll have to answer your question. No, I'm sorry, you already paid for me to answer that question. You spent a lot of money to go to school. Jason Wampler, rocket building and engineering. Anyway, what a shame. Don't ask for your money back, I'm broke. Anyway, okay, so we have that. Now the side cut, we want, this side is a little bit higher than this side. It's not really that noticeable, and I can even it up with a square sander. So I'm going to leave the black tape on. I didn't really want to do that, but the imaginary flat plane, the imaginary straight line parallel to the inner walls, the inner diameter, the inner walls, the inner diameter of this tube, and that tube. All 3 of those lines all land dead center on the same plane, or if you have the motor tube set up, the central fuselage, yes, they're supposed to line up dead center on the same plane. Now, in relationship to that, the imaginary flat plane, which is basically a dead flat surface, it's imaginary, but it's there to help. This blade, as mentioned before, has absolutely positively got to be at a dead right angle. Pick 2 imaginary points, not along the surface, but just 2 imaginary points, equidistant from both points, same side but same height, opposite sides of this blade, and they need, when you set this on this plane, they both need to be at an absolute 4 square right angle to that imaginary plane along the long axis. That way you have this setup as well. Now, like I said, there's craftsmanship's involved. I'm a little worried that this thing's going to weigh too much, so I'm going to work on my craftsmanship, and that craftsmanship, that was a Freudian slip, my craftsmanship in that regard. However, it's not absolutely critical. There are things that you can add to your rocket, such as fluid clutch stators for your fin can. You put at the base of the rocket. Right now, they only have that for single engine rockets, but it works brilliantly. Somebody did that. Somebody invented a fluid clutch, basically like an oil clutch for the fan for the radiator in a big Chevy truck, like the old Chevy trucks. The old Ford trucks have the same thing. The engine turns to fan, but a fluid clutch, when it heats up and expands, it grabs down the fan, causes it to spin faster because your engine's gotten hotter, so you need to draw more air over the radiator. A fluid clutch is the same thing. A fluid clutch is like a fin can. It's like a barrel that you attach the fins to, and you put it on the base of the center of the only fuselage on a single engine rocket, and then you don't even cant the fins. What happens is, for whatever reason, when you're looking at you're getting telemetry from a rocket that's just shot off the pad, you're always going to see the tail corkscrew. This is very apparent in staged rockets. You're going to see the first stage of that rocket rock around in a corkscrew pattern or a pigtail pattern, like it's a broomstick, like the damn thing's ready to break off. I don't like 3-stage rockets. That's a personal opinion. That's beside the point. The point is that tail corkscrews back and forth. Those 3-stage rockets, because long axis body tube strength on the first stage with all those 3 different segments attached, all the strength is shared between 2 different major couplings that join the 3 major sections of a 3-stage rocket. For example, you got that minus the gap, which is a tolerance between the inner diameter of the tube that the coupler is used to join the sections with, and then another tube. So you've got that gap, you multiply by 2. That's how much that very, very bottom section of 3-stage rocket is going to be allowed to toggle around. Under full thrust, that bottom motor, that's 3 motors in 3-stage rocket, that bottom motor is going to be doing all the work, and it's going to want to break free, and it's going to be working against the gap that's between the 2 couplings that join the 2 upper sections. I don't like the way it looks. They work. They've been getting away with it for a long time. I sure as heck don't like the way it looks. I don't like the way it performs. That you get this visual data, and it sticks in your memory. For someone like me, I'll never forget what I see. When I saw that, it was a downward-facing camera after the launch, and it was a running as a video camera, not taking pictures, taking video of what it looks like the downward angle of a rocket as it's taking off the surface, and how high they actually go. Well, in regular normal rockets, single-stage rockets, they do the same thing. They corkscrew and shake and everything. Back to the fluid coupling fin can that I was talking about. 4-fin rocket, 3-fin rocket. The fin can is a viscous coupling that fits in the outer diameter of the base of the main rocket tube, and you attach the fins to it. The 3-fin, 4-fin, even if you want to get as wild as 5 or 6-fin, whatever floats your boat. In my case, 6-fin. If it's going to be a single fuselage rocket, it's going to have 6 fins. And that's what we're going to do with the other one. But again, I don't want to get sidetracked. That fin can allows those fins to twist because evidently there's spiral laminar force forcing down on the tail of that rocket. As that rocket is in its, oh boy, people outside are hearing me act like a fool. As that rocket is under propulsion, as it is under force from propulsion from the thrust exhaust of the rocket motor itself, be it liquid rocket motor, or be it a solid rocket motor, be it a hybrid rocket motor like Teflon balls and laughing gas. That's $100 per launch as opposed to $600 to $800 per launch, et cetera, et cetera. But when the rocket's under thrust, the laminar flow down the rocket tube itself tends to be curvilinear. And it rifles, and it puts a twist on it. When it bounces and when it whips off the edge, the right angle edge of the base of the rocket, it causes a corkscrew effect. And this is best get because I'm not world's greatest physicist. In fact, I'm not a physicist at all. But the rocket, when it does that, the rocket is made out of a craft paper sometimes, which I don't like craft paper unless it's wrapped in fiberglass and machined. If you vacuum bag craft paper with fiberglass, then it's suitable for sub and transonic. Craft paper rockets, even on down to 1 inch, are just not acceptable to me. The material just doesn't hold up. You leave them outside, they weather, the rocket bends. It's just, to me, they're trading safety and performance and durability for lightness, and I don't like that. You just build out of stronger, heavier materials and use a bigger motor. But again, I keep branching off this tree. That viscous coupling, it takes that curvilinear rifled, externally rifled curvilinear laminar flow of the air that is attaching itself to the rocket's fuselage as it's spiraling downward, and it hits those fins. Now, if it's curvilinear, it's going to hit the sides of those fins anyway, and it's going to try to make the tail of the rocket do this, like you can see with my hand. But it won't do that. Instead, it'll hit the fins. The fins will absorb that force, and you can actually see somebody had a downward angle facing on a rocket with a viscous coupling fin can, and it was incredible. That was one of the straightest and most stable flights I'd ever seen. And now nothing's perfect with rocket launches. They look straight where they're going up in the air, but they're actually shaking back and forth, and they're kind of going back and forth like this. And their midsections are designed to flex back and forth. They're broomsticking it up all the way. And they're designed to flex. If a rocket's fuselage was too stiff, at say 18,500 miles an hour, which is standard escape velocity for leaving the Earth's atmosphere, and the body was completely stiff and it didn't flex, well, the rockets would disintegrate. They'd crack. They'd break like tempered glass on something, like a windshield it's been hit by a baseball bat, or they just fold and they go off axis, which is called percussion. I'm not sure what the terms are, but rocket stability, if rocket stability goes critically unstable at 18,500 miles, it doesn't matter how big the rocket is. It's 10 stories and weighs 100 tons. It's going to KO. It's going to completely crash. I think my little girl Valencia just reached out and touched her paw on my shirt because she wants her attention. Cats are interesting. Whatever I'm working on, she'll look for the most important items she thinks I'm gonna need to work with, and she'll lay on top of it so that I do nothing but give her attention. And I tell you, I love her to death for that. She's just a wonderful girl. But if you don't want to be on the camera, honey, I don't think you can break my stride. Anyway, so the viscous coupling with the fins, preferably 4 fins, because 3 fins isn't really going to do the trick. You have less vanes on a windmill turning the water pump or turning the generator. 4 vanes is best. That's what this guy had set up, and I'd never seen anything like that before. But I'm sure it's marketable. I mean, if I had the money and I actually know what to think about, if they make something that'll fit my level 2 and it's acceptable, then I'll look into it. Putting that on my level 2 rocket, but I've already set the fins on my level 2 rocket, so maybe not. But when it turns, it absorbs that downward curvilinear, externally rifling laminar flow of air that'll whip off the right angle of the base of the tail body tube of the rocket and cause it to twist, but it'll hit the fins and the fins will twist. So the fins absorb all that curvilinear external rifling laminar downward force throughout its power, the powered portion of the flight. And so the fin can will twist. You're thinking, well, isn't that unstable because the fins are moving? Well, technically, the fins aren't there to flap their wings and help the thing go first class to the moon. The fins are added for stability. You enhance the fins' ability to stabilize that rocket's flight under power, which is the first phase of a standard rocket flight, by allowing them to move in a direction in relation to their attachment point on the rocket that absorbs the shock of all the external forces in the natural environment in a rocket's first phase, which is power portion of the flight, and keep it stable. It's an absolutely wonderful idea. Though thinking about it, though, that might have more of a military application. So I bet the person who created that might end up getting the government's attention, like the Army or the Air Force, and they're saying, "Hey, look, we have need for something like that, and it has some practical application." That individual could suddenly find themselves on the other end of a multi-million-dollar contract with the U.S. military. I'm not saying that's what I'm going for, but that's another thing. We finished talking about this viscous coupler. That's another thing about these rocket events. There's always one or two individuals there that just stand out as being, exceptionally sharp tools. They're the bright one in the bunch. And like the Gates brothers, I'm sure they've been sucked up by the U.S. government because they're absolutely incredibly brilliant. Cicerone Technologies. I don't know how much bigger they've gotten, but they have international offices. They're now a U.S. government contractor, low-cost weapons program, LCWP, for the U.S. Navy. It's no secret. I mean, they talk about that in sport rocketry, and of course, there are other sites for vendors to vendors that can communicate, like Thomas.net or ThomasNet. So, I mean, everybody knows that. But Cicerone Technologies started out making reloadable dry fuel rocket motors for model rockets. Gates brothers started out with a bang. They built a huge 6-engine single fuselage rocket painted various colors of purple, and it was on the color of high-powered rocketry. I saw the thing in person. I met one of the Gates brothers. He flew his aircraft into the Balls event in Black Rock, Nevada. I think one of only 2 of those events I went to, and I was really impressed with their workmanship. They showed the rocket after the flight. The rocket was scratched up. Rockets undergo that kind of damage. You just clean them up. They're ready for launch. After you clean them up and rebuild them, refit them with more motors, and rebuild the avionics, get everything set up. That's just how it goes. It was a big rocket. The rocket probably weighed about 200 pounds, and it was about 7 or 8 feet tall. But the reason I'm saying this is a lot of people, they get into sport rocketry, then they decide to get commercial about it. Like myself, I am going to be, I'm going to test flying these rockets, but eventually rebuilding and selling rockets on either Mercari or Amazon. But I'm having a terribly hard time getting Amazon's website to cooperate with my phone. So I can't upload documents. So I don't know what it takes with Amazon, but if I don't figure it out in the next couple of days, I'm just going to give up. I'll just find another place to sell my rockets. However, new development. I've just discovered you can build and publish your own websites, and you can do it for free. As long as you have a smartphone, you have access to the internet, or you have a PC or a tablet and have access to the internet. So I'm going to look into that as well. Instead of depending on other sites to list my stuff and obey their rules, I can set up my own website where I can give advice. I can have live stream classes, and I can also offer products. I don't just build and sell rockets. I build and sell rocket components as well. Bulkheads, centering rings, motor systems, etc., etc. You haven't seen any of that yet because we just met, and I think you're pushing a little too hard. I don't kiss on the first date, no matter how gorgeous you are. I mean, so anyway, so that's pretty much that. I really thought that viscous fin can idea was great because the downward angle of the camera showed an almost straight, stable flight. That fin can was spinning. It was taking up, absorbing all the force from that can antler rifle, externally rifled laminar flow. But it was interesting. But I tell you what, that made me really happy to see something like that. The only thing I'd have to say bad about this, kind of jumping back to this idea, I don't like the fact that it is wider than the base of the rocket motor tube. So it kind of sticks out. Fin cans themselves, I bought a 3-fin can one time. I put it on a 3-inch, actually 2.5 inch diameter motor tube. It was craft paper, but it's really, really tough craft paper. I got it from Aerotech. I got the nose cone from Aerotech. This is when I started building my own high-powered rockets. It flew fine, But it's just, I never could forget that the fact that the fin can, I got the fin can online. They're basic shaped fins. It worked great, very, very stable. But because it stuck out above the surface of the base of the side of the rocket, guess what? If you're going to put a launch log on it, you have to put a launch log on a standoff on the top of the side of the rocket, or maybe even two. But the little tube, the little launch log tube. Let me get this other student rocket to demonstrate. See, on this guy right here, which I think I want to work on more too tonight. Oh, look at her. This right here is the launch log. You put the launch rail through this, which is just maybe a round metal stick or rod. The problem is with the fin can, that adds extra width right here. The problem when you go to launch this on the launch on the launch rod, the launch rod needs to have a straight shot down the side of the rocket tube, and if it's going to hit the width of the fin can, your rocket will still be able to reload it on the pad. But the problem is, it's either going to bend the rod, which is going to affect the takeoff vector. The rocket's going to launch at an angle, or it's going to bend the rocket on the stand, and the rocket is definitely going to take off at an angle. That's going to affect your trajectory. You're going to have to do a whole lot of special geometry, because if you're in a small space, guess what? You're going to chase the small rocket a long ways. You don't want to do that. You want the rockets to launch as straight as possible, no wind either. There's another thing I was going to mention too that affects rocket stability, but I guess we're not going to talk about that. Oh yeah, that's right. One other thing. By the way, folks, I read an article that was really funny. And I understand people are new to the concept of building rockets. And the article is describing. Excuse me, I have to stand up a little bit. The article is describing a teacher's encounters with students who are new to the concept of building model rockets. And people are interested. I understand you make mistakes. We're describing things like the fins weren't even with each other, the fuselage. Like, yeah, 23 years later, I make the same mistake. But some of the students were taking single-use motors and gluing them in the motor tube. Well, you're not supposed to do that, because once you launch a rocket, that's it. You're supposed to remove the motor that's spent and put another one in, because they're single use. But if you glue it in, it's a permanent fixture of the rocket. So guess what? You either hang it on your wall or you throw it away. You can't launch it again because you can't remove the single use motor. So, yada, 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 et cetera, et cetera, et cetera. But a common mistake, and you know what? I'm a bad example. I'm a hypocrite for saying this. A common mistake is to load what? Look at this, guys. Look, and this is the teacher signing his own confession. What did I do? I put the launch log on before I did what? Before I did the ruts and attached the fins to the base of the main fuselage itself. Why is that a problem? Because if I set 3 fins, chances are I can miss a straight angle line of sight of where the imaginary space where the launch rod needs to go. With 4 fins, I'm running more of a percentage of actually setting one of those fins directly in with interference in line of sight of the launch lug. Now this rocket's going to be a 6-fin, but guess what? I'm going to have to stick a rod down the length, down this tube, down the length, and mark the space, a dead right angle, a dead even axis, so that I do not mount a fin on that line. And you want to know why? Because if I do, now I'm mounting 6 fins, so I have almost a 100% chance. If I don't take that step and mark where this tube is and where it needs clear space for that launch rail, guess what? If I'm mounting 6 fins, I've increased my odds to 100% that I'm going to mount one of the fins and it's going to interfere with this hole right here. Okay, so I made a big boo-boo. I made a decision to make this a 6-fin rocket. I probably made that decision like last night. And I want to address things. I want you guys to be impressed with this rocket. But I just thought of that right now. So, as a consequence, as some advice, some helpful advice, take it from somebody who's 53 years old, Every day is a learning experience. You're not perfect. Even the old guys like me make mistakes. And I got to tell you, I was around when they invented steam-powered television. One of them almost blew up and gave me third-degree burns, like being near a chicken boiler. So, anyway, but that's pretty much that. So, what I'm going to do is probably sit down and write things out in my melted hieroglyphic box-shaped chicken scratch, which is my writing is almost impossible for me to read. But we're going to develop diagrams and numbers and letters. We're going to tell you step by step how to build a rocket properly. Single engine rocket with my system or my shared idea system of reloadable motor. Along with cooling baffle and lower anchor, which I should have installed before, not after. That's the second mistake I made, but I'll explain that later. Plus the shock cords, the parachute, the upper nose cone, the upper spool for a recovery system in the nose cone section. The variety of ways to fabricate a coupling. God, folks, by the way, unless you have the right tools to make fins properly, you're going to hate it. So I'm going to recommend certain tools. It's either that or buy prefab fins off the internet. My preference, G10 1/16, G10 3/16. Write that down or commit that to memory. G10 3/16. That's standard apple green, high quality fiberglass. It's American made. Don't get anything Chinese made, only because it doesn't work very well with cyanoacrylate, and the surface quality is so bad. Then you go to machine the ends and it turns rubbery and fuzzy. Get American made apple green G10 3/16. We're going to be doing rockets that are up to 1.25 inches. 3/16 G10. Get 3/16 phenolic. Same thing, very machinable, high pressure, high quality. Looks from a distance looks like plywood. It is not. Another option is a 3/16. If you can find it, 3/16 Garolite, which is or Bakelite. That Bakelite Garolite double X or Bakelite. It's a black carbon or carbon fiber version of I'm closing my eyes to of phenolic. So you got the phenolic, the Garolite, or the G10. Now, a fourth and final selection is actual ABS itself, but you're not going to find thin-walled ABS. The best you're going to do with ABS is probably 1/4 inch wall. So we use those for the big projects. However, colorized flexible mylar that comes in 1/8 of an inch, 3/16 or 1/8 of an inch thickness. Mylar, if you want to make, I'm so sorry. I woke up early this morning. 1/4 inch. I'm not one. Oh my God, excuse me. 1/8 inch thick mylar. 1/8 inch thick mylar is the only plastic that I would recommend for mounting on PVC body tubes or even ABS body tubes. But we're sticking with thin wall. I call Schedule 80 PVC body tubes of anywhere from 3/4 of an inch to 1 inch to 1/4 of an inch. You know, we have enough to learn, so I don't want to spread too much of a wide net. And I'm already, neck deep into the double engine job here. So you got the Mylar, you got the Garolite double X, you got phenolic, which you can use for a variety of things on the rocket. In fact, you don't use phenolic on almost anything on the rocket. And then of course you have G10 fiberglass, the apple green stuff. My first choice is G10. So when I get some money together, I'm going to set up an account with Grainger and order some 3/16 G10, a couple sheets. The stuff is very machinable. Grainger.com carries almost exclusively all American-made parts and supplies for the industrialist, the engineer, the maintenance mechanic, etc., etc. And there's nothing. If you can't find it on Grainger, you can find it on McMaster Carr. Now, McMaster Carr has a load of Garolite double X, phenolic, and fiberglass. Grinder is going to be your stuff where you're going to get your pulleys, your bearings. The grinder is going to be going to get your, excuse me, I didn't say that, your fittings for the shock cord material, safety handling equipment. When you're working with cyanoacrylate, it'd probably be the good idea to wear gloves. I don't, I'm a hypocrite for that. But anyway, so you have your 3 selection of materials for fins. Garolite double F, or excuse me, Garolite double X, 3/16 width. Nothing thicker. If you want to go with 1/8, that's fine. But I gotta tell you, those big fat blunt ends, it's gonna create air resistance. You're gonna want it around the tips. It's just extra machining work. 3/16 Garolite double X. G10, 3/16 G10 as first choice. Garolite second choice. Phenolic, 3/16 phenolic. Fourth choice, like I said, is Mylar. 3/16 Mylar. It's gonna be too flexible and too brittle. It's your fins are going to want to bend over, and they're going to push against the rods or the root slot, and they're going to break. So if you're going to go with Mylar, which I do recommend, it's a wonderful plastic, and it's not that expensive either. You can get it in an arts and crafts store. You're going to go with, you want to go with 1/8, which is basically 1/16 fatter. Oh no, I'm sorry. 3/32. I'm sorry. Let me start over again. Oh no. Okay, so G10, 3/32 G10. Excuse me. Forget what I said before. 3/32 G10, 3/32 Garolite double X, 3/32 phenolic, or 1/8 Mylar. 3/32 is 1/32 thinner than 1/8. So you just have to do math. You have to do fractions, principles of fractions. Oh my goodness, math makes me cry. But those are your specifications. I hope you remember this information and write it down. This stuff is benchmark. This is reference information that you can use to help you build your next rocket, with or without my online assistance. Folks, we're going to bring this video to a conclusion. I'm going to have some red tape that I have to go through to load this video up. I'm really happy that you're watching. I love you guys. I'm looking for sponsors. Hit the like, hit the subscribe. I may form a club to join, but I'm not sure. And leave a comment, post a comment. All comments are welcome, whether good or bad. America's the land of free speech. I want you to feel free, use your power to speak, and share ideas with the entire rocket building community. Anyway, that's it. We'll see you next. We'll see you next time. Thanks a lot. Bye-bye. By the way, can you tell the show's not scripted? You think?